Now, the next step is the dynamic memory allocation. So what is that? Let's do some examples and see what happens. First, let's declare an integer variables. When you declare integer variables, there is a space reserved in the memory of their computer, and the space reserved has the same size as one integer. And then when the function return, this space will be automatically released. But what happens when you don't know how much space to reserve for a program? Let's say you might receive an undefined um, input number. Let's say the user input some informations or message, but you don't know um, beforehand what is the length of this message. So you'd have to reserve space dynamically at runtime. This is what we call dynamic memory allocation. It is a memory allocated at runtime. And you'd also, as a programmer, type in the instructions to free up those spaces when you finish using it, because it won't be or will not be released automatically. So let's say we want to reserve a, a space needed to store one integer or an integer value. I'm going to include the std library. This is a library that contains some helpful functions like the malloc function, memory allocation. The malloc function uh, uh, request uh, the memory space we needed from your computer, and the computer might allows us to will reserve this space and return a pointer, so we can use that pointer to use that memory, which means that we have access to that memory location and we can use it without issues. We have a permission to modify and do whatever we want in that memory locations allocated to our program. Let's say we want to allocate a memory space uh, for um, an integer variables. So since the malloc or the malloc function returns a pointer to the reserved space, we have to use a pointer variables, and the space we want to reserve will be of the size of an integer, one integer. Great. So there is something we call casting. We are not required to do it here because the compiler will guess the types, because here we are assigning the address or the return address to the pointers here, and int pointer, an integer pointer. So the casting will be automatically done. What happens when you cast the return address? It means that it tells the compilers how we want to use the allocated memory address. Maybe you want to use it for char, or you want to use it uh, for an integer as an integer variable. But sometimes you might also want to uh, use also different data types. Then you might want to cast the return address into another data type. Great. And we can assign values to that returned that memory location as usual, using dereferencing for pointers. So I can assign 182. Basically, there is almost no difference between accessing an already known address from a variables or an address allocated. But at the end of the program, you always have to make sure to free up the allocated memory space. So that's what we do here by using the free command, the free function. I'm going to display the value and we'll see what is in there. And let's include the stdio library and let's compile. So that will be gcc main.co, then the name of the executable file. Then let's run. We see 182. Great. So now, if you look into in the doc, the malloc function actually return a void pointers, which means it is an address, but we've not specified yet the ways we want to use it. We can use the allocated memory space as an integer, as a char, or as whatever we want. But we always have to make sure that the reserved space is big enough to store the information we intend to store. For example, you don't want, for example, to reserve a memory space of the size of a char while you are using it as an integer, because an integer value is bigger than a char. So your program might crash because when it tries to store an integer value in a char memory location, the memory space is not big enough to store an integer value. So always make sure that the memory location is big enough. In our case here, we are using it as an integer. So we want to store one single integer. Great. Next, let's say two we have two strings and we want to concatenate those two strings. But how to do that? I'm going to delete all this. Let's say your program might receive two strings of different sizes. I'm going to call this one string 1, hello. And I'm going to call these other strings str2 world. Great. And we're going to declare a pointer type, a char pointer types, which will store the memory locations. A pointer to the memory location we're going to reserve. So the memory location we're about to allocate or to request has to have enough, should be big enough. The memory space should be big enough so that we can concatenate or copy these two strings into that memory. So the first thing we'd have to do is to compute the length of str1 and str2. Visually, we can do that, but when your program receives, for example, command lines, arguments, you don't know the lengths of your arguments beforehand. You'd have to compute the lengths first, then after that, allocate the necessary memory space, then continue with the code. So let's compute the lengths of these two strings. So I'm going to declare a variable called length and I. So length is equal to 0 and I equal to 0. Okay. So wow, str1 plus I is different than the null character, we're going to say I plus plus. Then at the end of this, we add lengths, I to lengths. And then we compute the length of str2, then we add that to the length. So then we have the length for the concatenate strings. So we initialize the I to 0 again. So while str2 plus I, or we can just say while str2, this is another style using the square bracket notation, is different um, than the null character, then we say I plus plus. Then after that, we say length plus 1. Great. So the length, length plus I. Now we know the length of the two strings added. The length of the concatenated strings will be the length of the first strings plus the length of the second strings. Then now we are ready to allocate the memory space. So now allocate enough memory space for str plus str2. So this newly allocated memory space, a pointer will be returned. Then we assign this pointer to our as variables, which is a pointer to a strings or a pointer to uh, a char. We call the memory allocation function. Then we say we want to store enough space to say we want to reserve enough space to store one char times length plus 1. So this will reserve um, a memory space big enough to store the values from ls, to copy the values of str1 and str2. We add plus 1 because strings must always end with the null character. So this plus 1 is for this for the null character we want to append at the end of the strings. The next step is to check if the memory has been allocated or not. If the memory allocation was a success, we will have a S will be different than null. But if it wasn't successful, the malloc function will return a null so that we can know that there wasn't enough space, or maybe something goes wrong, then we're not able to have enough space to store the string. Great. So if the S, or if the return address is different than null, then that means we have now access to a memory location, and the first address, it has been returned. We can use that first address and loop over to get access to the other addresses. Now let's copy I'm going to start with I is equal to 0. Then we copy the str1. So while str1, so while str1, I'm going to declare another variable so that we can loop over str1 and str2. I'm going to call it k is equal to 0. Okay. Now here we have, well, str1k is different than a null character, then we will have the si equal to str1k. Then we increase the I for the for the concatenated strings, the result, and we increase the K for the str1. Then next we want to add in the str2. So we have to initialize K to 0 again, then say while str2 K is different than null. So Si is equal to str2, then K, the index, then I plus plus, then K plus plus. So if you notice is that the I, we initialize the I to 0 only once because the I is used to loop over the main or the resulting strings, the concatenation result strings, and the K is used to loop over the other strings that we want to copy into our resulting strings. So here we only have to initialize K to 0 for us to loop over str2 and assign it um, to this in the S string. Then at the end, we have to add or append the null character because any strings have to end with a null character. So now we have str1 concatenated with str2, and the resulting string is S. So if there has been enough space reserved, so we can add in the str1, then add in the str2, then after that, we append the null character and we're done. And next, we're going to print the S strings and see what happens. So let's compile this code, gcc main.c o, then main. Great. Then let's run the code. Yeah, we see that it displays hello world, which means str1 and str2 has been concatenated successfully. So this is all for memory allocation. I'm going to show you something else, but I guess it's important to know about. We can declare a variable called void, which is a void pointer, and we can say malloc size of char. So we reserved a memory space big enough to store a single character. For the moment, the ways we plan to use it is not defined because a void pointer point to a memory location, and that memory location we have not specified yet how to use it. Maybe we want to use it as a char, maybe as an integer. Let's say we want to use it as an integer. So we have to declare a variables like that, be int, and cast the address to an integer type, or we want to use it as a char. We can say we create a pointer for a char, then we cast the address to a char. So the compiler, when you try to use this address or this pointer, it will consider that the allocated memory is a memory space big enough to store char variables. But this is not very good here on the line 8 because an integer is bigger than a char, so we can't use such a small memory space to store an integer value. There is two ways. So you can say you want to store an int, or you want to store a size of a char times 2. So that way you know that it is big enough to store an integer. Maybe we might say 10. It's still big enough to store an integer, but for the sake of uh, optimization, we want to reserve only the space we need. And every time you finish using those spaces, you also have to make sure to free up the space with the free function, else your program returns and the space is not freed automatically. That may cause problems later, or your computer might even crash if there are, or other programs might have problems to allocate memory spaces because uh, your program has reserved memory space but did not return or restore this memory space back to the operating system. The next example will be to create an array of integer, then we loop through this array and displays values. So I'm going to create an int array, then call the malloc function, size of an integer. We want to reserve a space for like 21 integer. So we have now 21 integer memory locations where we can store our integers. And now we're going to loop through this integer array and initialize its content. So that will be for I is equal to 0, I lesser than 21, and I plus plus, we say I array square bracket notation. Then we say I times 2. So each index times 2. Next, we are going to display the array. So I is equal to 0, I lesser than 21, I plus plus. Then we use the printf function to display the value. Array, then I. What you see here is that you can, for example, create a variables like an n variable like that. and say times n. The n variables might have a value depending on maybe different factors. Maybe the user inputted some values, then you allocate memory according uh, that to the user input. So I can just say I lesser than n, I lesser than n. Great. Let's compile this code and see what it does. GCC main.c, the output file name, then main. Let's execute, and here it is. We have displayed from 0 to 40. I'm going to add a line break. Let's compile the code again and see what happens. Yeah, so we see that 0 times 2 is 0, 1 times 2 is 2, and 20 times 2 is 40. So we have the indexes multiplied by 2 and assigned to the elements of the array. I want you to notice that we cannot do something like that. We cannot declare an array based on, we cannot statistically declare an array based on the value of a random variables. This is not possible, but we can dynamically declare, or we can dynamically allocate the memory space for our array. So now next, do not forget to free the memory space you have allocated out before the function returns. If the function returns and you did not free up the memory space, the operating system will not or might not allocate the memory space to other programs already running on your computer. And that may cause some issues. You might want to reboot your PC because uh, the operating system might say that there are memory spaces that are being used while your program has terminated long before. So that's for memory allocation. And this is just a small demo to give some light on this thing. Thank you, and well, and see you for the next session.